Hello everyone, welcome to the RollCall breakout on basically the kickoff for the L2 EVM Common Core project. So basically, the idea would be to have two parts. Basically, first start as the agenda in the GitHub issue said. First, basically start with the meta section on discussing now that people have heard the idea from the last roll call breakout from a while ago, and then also at DEF CON there were some more conversations. Um, Basically, how much interest is there in general? Basically, we have the Rollup Gas project as basically a way to make sure that we have a version of all major clients now that is willing to support IP-specific features. Is this enough for like a pick and choose world, or would it make sense to have some sort of shared feature set defined that multiple L2s basically opt into supporting to make it easier for tooling to basically support? So that's kind of the first question. And then if we basically do think we have critical mass here to move ahead with the Common Core, basically what should be the general kind of scope or type of features? There was some interesting conversation there at the interop day at the end of DEF CON. And then in the second section, more concretely, talk about assuming people do think it would at least make sense to work towards a Common Core version 1 and then make a go no go decision once we have that. Is concretely talk about what features, meaning existing EIPs, existing IIPs, or IIPs that are yet to be created, should be part of that kind of like first version, and a concrete decision like what version of the L1 EVM should that basically be based on, which hard fork, if that makes sense. So then let's start with the first section, the meta section. Assuming that maybe people on this call have had some time to think about this, are there any thoughts, any updated thoughts that people would want to briefly talk about on like whether for their projects, in idea like a shared EVM standard as a basis across L2s would make sense or not? Yes, Eric?
Hi. I hope the noise here was reasonable. Please tell me if it isn't. Um,
Yeah,
so,
sounds good.
okay, perfect. I'm with Fireblocks. So from the wallet side, we obviously integrate a lot of blockchains, right? Like we integrate more than 80 blockchains today. A lot of them are what's like, we refer to as EVM compatible, which is a complex statement. So I think for us, it's meaningful to have standards that combine multiple blockchains. And the fact that we have some definition, even if it's not perfect, of EVM compatible is what allows us to scale integrations of EVM compatible chains much more quickly than new L1s. To some extent, we like have a different clue if you're an EVM compatible or not an EVM compatible blockchain. Same goes for some other compatibilities like Cosmos compatibilities and that. So having additional standards that are applicable to a lot of blockchains and not just one blockchain, and by blockchains I mean L2s as well, just means that we can be much more scalable in supporting those new features, right? So instead of each and every single blockchain having to come to us separately and asking if we're willing to support this ERP or not support this ERIP or those kind of things, when we know that there's basically 20 blockchains that are going to be supporting some standard like Common Core, and they're all asking for the same feature, that feature can be better prioritized. So I definitely think that there's value in those additional definition layers if they get meaningful traction from the entire system.
Right, thank you. Yeah, that's actually a really good perspective. We haven't really heard much from the wallet side yet in this process, so that's actually very useful. and I think that mirrors kind of the intention at least behind the Common Core approach. So that's good to hear that seems to resonate. Harry?
Um, Hey, just and I've still haven't been as quite as involved in this as I wish I had, just because I'm excited about the effort and definitely looking forward to it. Um, I think one thing that comes to mind, and this is definitely sort of like just the question of sort of Aragon already exists. We already have one case where we kind of started with Geth and said, hey, let's start making improvements to it, and kind of like fractioned out, and like they are sort of they I think went in a direction of like relatively substantial changes. So I think, in presumably in the kind of roll up Geth mindset, the goal will be sort of a much more limited diff, just because sort of the thing that Geth has going for it is stability and kind of how tested it is, and it'll be interesting to sort of modulate how substantial like the willingness to maintain changes are. And I think this is going to be interesting because it's going to come up a lot in terms of various performance related questions. So like, for example, I think the Geth team historically has not had much interest in optimizing for block times that are faster than Ethereum block times, just because they're very focused on having the best possible Ethereum experience. Um, but whether or not kind of there'd be interest in roll up Geth in optimizing more for certain things that you care about a lot more when the block times are faster.
Right. Yeah. So basically, the way I would think about it is that to unlock more, having more IPs shipped to L2s, basically, they're two, in a way, two pillars. There's the client side, and then there is the EVM standard side. And so um, basically what rollup get was aimed at was basically to unlock the client side and make sure that no matter which clients kind of the L2 choose to go with, that there is kind of there's a client that is basically out of the box, focused on the kind of the L2 specific challenges. And so yeah, I think the intention here would be, I think we have both people from the Geth team and from Rob Geth on the call. I think maybe if someone from the Rob Geth team would want to briefly kind of talk about their approach in general to like basically the aim of roll-up Geth, but then also say the support for Common Core project. But just to clarify, right, that this is all more like as a bit of a recap of the general roll call process there, because even if the Common Core basically ends up, if we decide that there's no need or no room for the Common Core as a shared basis, that even then still having clients that support individual IPs would be very useful. But if do we have anyone from Rock Geth?
Okay.
Absolutely. Sorry, and just to clarify, like the sort of purely just implementing the common core RIPs, I think is very exciting, and definitely like I think we're quite interested in off-chain labs. I was more just kind of interested in sort of the where the scope was cut off for kind of what was being considered.
I think you can think of it. I would like if people here thought of it the other way around. So instead of coming and asking Rollup Get team, are you planning to consider this or consider that? Think of Rollup Get as the place where if there is consensus among layer twos about a particular feature, a particular improvement, a particular whether it is performance related or an RIP or whatever, we will support it in Rollup Get. So instead of thinking about this team that you go and you ask whether they are willing to support a particular feature, basically go to the other layer too. So let's coordinate. Let's think, oh, do we all want this feature in particular? If the answer is yes, rollup get team will implement it. Doesn't matter what it is, right? Or at least we'll engage in the discussion. And but it's not like we're here in this far away place and you just come and ask, oh, are you willing to do this? Are you willing to do that? No, it's not like that, right? So we come together here, every layer two, Every rollup brings up their opinion. We discuss it, and if there is rough consensus that the feature will benefit the majority of the rollups, we'll implement it, and that's it.
Right. And so of course the nice thing is that the Common Core is basically like a good starting point, because the Common Core by definition is basically the on the EVM feature side, that's basically like this the base kind of agreement of features that are interesting for several L2s. And then of course there will be individual IPs on top of that, that say are still implemented by several L2s, but not say by everyone in the Common Core. That will also be supported presumably by all the L2 clients. And then there of course also things beyond just EVM features, or like execution features, right? Like things that are not spec changes, but more general usability improvements aimed at L2 specific needs. Yeah, and RollCall basically is supposed to be like a coordination place for all of these. Right. Back to the kind of the more narrow kind of Common Core ideas. Were there any further kind of general opinions or takes on it? Or otherwise I have some more specific questions to get us more down the path.
There are a list of suggested RIPs for Common Core already. Like, you recently joined.
Right. Yeah. I mean, so basically that's in a way what this call is about. I have some. Maybe I don't know. Let me briefly share my screen. I just wanted to get started with making sure that there's some general agreement that going forward with this idea makes sense. But let me see. Let me share my screen. Share screen. Oh, that's new. Okay, can you see my screen, or there was some new macOS pop up? I'm not sure if.
Yep, we can see you.
Okay, perfect. Yeah, this is just that was just basically so in the last RollCall breakout presentation, and then also like this is the version of the slide from the DEF CON talk. I had some general kind of examples for types of changes that could be relevant for the Common Core, like but those are not specific to the version 1, but more as like a general sense of types of features. So repricings, native transaction types, things like small and specific changes like the delayed state of computation, but then also like bigger features like native account abstraction, transaction parallelization, potentially some sort of solution to kind of state growth, multi-dimensional pricing. All of these, none of this would definitely, like, all of this of course is just kind of my take of potential questions. And then I was basically I tried to come up with some specific list of individual candidates for first version. This is not a non-conclusive list, of course, right? So like I'd actually be curious to get people's takes on this, but maybe before we go into the individual kind of candidates here, like maybe the first question would be like what should be the general scope of a Common Core, right? So in particular, I think Protos is on the call. There were some conversations at the Interop Day at DEF CON, where basically one of the questions that came up was basically they are, well, I would say maybe in a way like 3 different versions of Common Core. What my initial idea was is basically that it really is similar to like hard forks on mainnet, that it is like a set of full features that have reference implementations in the individual clients. And then, of course, can be adapted as usual by the individual tools. But then there's also the alternative versions of so Proto from the OP side was saying that there might be more interest in just saying only base EVM changes that allow for better extensibility. So specifically on this list, there is the second EAP mentioned is the 7685, which is general purpose EL requests. I'm not sure how many on this call are familiar, but it's basically like a feature in the upcoming Pectra hard fork that Proto mentioned as something that happened to be like designed in a general enough way that it really allows for much easier extensibility of this part of the kind of the execution system. And so basically he was saying that a common core that is just focused on these types of features might be better, that then leaves the individual features on top up to the L2s. And then there was also like an idea of basically say having the common core only define interfaces, but leaving the implementation still up to the individual L2s. So maybe before we dive into the individual questions, the individual features, do people have opinions on like would it make sense to have like a common core based around actual features, or just like making the EVM more modular and more extensible for the L2s, but leaving the extensions up to the L2s? Yeah, I guess makes sense. I mentioned Proto, that was your take, so go ahead.
Yeah, I think we should stop conflating the EVM and the wider execution layer. I think extension points are especially valuable in the wider execution layer, but within the EVM, we have tooling that does not have many interfaces to work with. And I mean, there's only a limited namespace of opcodes and so on, and it would be bad to diverge there. So within the EVM, I'm very much for more collective feature iterations. Whereas outside of the EVM, but within the execution layer, I think there's a lot of opportunity for good extension points.
Right. Yeah, that's actually a good take. I keep reverting back to saying EVM because it just mimetically so simple. But you are right. We should actually maybe start calling it the execution, like the Ethereum execution system common core or something. Uh, it's a bit more of a mouthful, but yeah. So basically, specifically, maybe that's also good to clarify for people who are not part of the conversation. So the intention would be for the scope of this to include all things execution. So there might be some logic, for example. I mean, in a way, even the transaction type, right? Like most of that logic is from outside the EVM before execution actually gets started. And there are other kind of parts of the broad execution that's not just the narrow EVM that would be part of this. But yeah, it's a good kind of clarification to say that like within the EVM, actually focusing on features makes sense. Do other people? I mean, otherwise, I think we can just talk about the individual features, and then things will get clear there as well. Yeah, let's yeah, Harry, you had one more?
Oh, just a small comment. I definitely agree with most of that. I think the only thing I was going to add is like I definitely think either like the set of things that are kind of not of interest to Ethereum, so like 2D transaction type being a great example, or the things that are kind of like generalization are definitely like more exciting to me than things that Ethereum is actively working on, like EOF, where like rollups could front run a little bit, but I get more nervous there versus sort of working on things that are not as much interest elsewhere.
Yeah, that makes sense. I think in general, front running mainnet EIPs is a dangerous game, and because you don't want to be in a situation where then you can't like once it's actually shipped on L1, you have issues with different versions, or slightly incompatible versions or something. That is in general a question that of course will at some point be unavoidable, because as we start having more IPs shipped, I know several of you, for example, have already shipped the IP 7 to 12, the R1 curve. that is at least a very plausible candidate for a future mainnet fork as well. And it's not guaranteed that it would be shipped in quite the identical form. So in small ways, this will be something that eventually we'll have to deal with anyway. But of course, trying to keep those conflicts minimum. Makes sense. Yeah, I don't know.
Charles.
Charles.
Yeah. Yeah. So if you have a decent set of implementations of something like 7212, and the mainnet says, oh, actually, we want to do this too, then you would hope they do it the same way. And largely that's a case of if you've designed it reasonably sensibly and thought, is this going to work on mainnet? And a bunch of people who do L2s can answer that question, then it's much easier for all core devs to say, yeah, we will pick this up and do it the same. So if you're working on something that might conceivably be a front run of a mainnet EIP, part of the thinking should be we should probably think about how to make sure it's going to be compatible with mainnet if they decide to pick it up. But yeah.
No, I mean that sounds very reasonable. Actually, so basically the idea was to use the R1 curve specifically as like a example for figuring a lot of this process out. For now, as kind of the IP process got off the ground, L1 was the kind of the core dev side was not willing to necessarily commit to basically taking over IPs in an unchanged way, right? Basically, like just because they wanted to see kind of how that process got going. So I think actually it's a nice kind of like small enough change that it really, I think, will be a good way of testing how people feel about this. And then as these questions become more apparent, then also like we will start to find better ways for L1 core devs to maybe be a little bit involved in the L2 IP process so that they can be aware of the kind of changes that are in the pipeline and maybe can get feedback on which version of that at least has a good chance of being able to then be taken over by the L1 in an unchanged way. But yeah, I think all of this will have to be figured out as we go. And so like for a first version of Common Core, probably indeed makes sense to keep it at least relatively light in terms of features that might also be relevant for L1. Yeah, and specifically if we look at the few candidates, and again, like if you have ideas, if you have specific things you would want to see on there that's not on this list, like that would be really good to mention here. But basically, what I came up with, so the first question would be in general, like any Common Core version would have to define which version of the mainnet EVM it is based on. The obvious candidates there would be basically Denkun, which is the version of the EVM that is live on mainnet today, or the upcoming but close to being fully locked in spec-wise kind of Pectra release, which is the next hard fork coming up. And then there's already individual features in the pipeline for the fork after, which is called Fusaka. But there I would recommend that we would, if there's interest in things like EOF, that we would pick the individual EIPs instead of basically trying to be equivalent with what is still very much a moving target. Yeah, is there any? I don't have a very good overview of like the exact EVM version that all the individual L2s are using. So I don't know, for example, what the latency there is in terms of general equivalence with the Pectra EVM. Would it be feasible to use kind of Pectra as a fork-off point, or would it be more practical to take the today's Denkun EVM and only add individual EIPs from Pectra? Do people have opinions on this? Yes.
Hi. Yeah. So it's I think starting from Pectra makes sense because it's not like if today we decide we start from Pectra, then tomorrow we have everything merged and ready to ship. It's going to take some time, and assumingly will like still have the option to not use Spectra features, even if that's what like the it seems like there is some confusion between what's the code base and what's the standard, right? So the code base should absolutely have everything Spectra that it can have. Like there is no reason it shouldn't. As for the standards, I assume different rollups can still find what they need and enable what they need. But eventually, if you start working now on some code base, it's still some time ahead before people merge it, and then sometime yet before that gets shipped into our rollups.
Yeah, so in general, I think pretty much the same. Like I think there's no point in trying to choose which EVM we fork from, because like in the version of the EVM that you or the version of the client in general that you use is just something that you configure when you launch your chain, when you start your client on the chain spec on your Genesis file. Like that's nothing to do with the code base that you use. Like if someone doesn't want to use Spectra feature, they just don't enable it in the configuration when they launch the client. That's not something that you need to make a decision on the code base. Like code base is always up to date with the latest Geth version, and that's it, right? The exact version of the spec that you use is determined by the things that you activate when you launch your client. That's not something we need to worry about. We don't even need to think about that.
Right. So, but like I think it makes sense, yeah, to explicitly make that distinction between the code base and the standards, right? Like with the idea specifically with the common core would be to have as a spec target that is a set of features that all the L2s that choose to follow a common core and say announce, say by this time, this date, we will be on Common Core version 1 or something. That would mean that like all the features that basically are part of the Common Core spec then would be expected to actually be supported by the individual too. So for example, if there's anything in Pectra that people would specifically not want to be part of that initial target. So for example, if someone was like, hey, BLS seems interesting, but just a lot of cryptographic overhead, we don't actually like, it's going to take us a while. We wouldn't want that to be part of the initial feature set or something. Then it would be preferable if we say, okay, like the set of features that everyone basically supports does not include this. We could, of course, and this is I'd be curious to hear people's feedback. We could it could of course also make sense to define the Common Core as purely like a diff, so basically just a set of features, and it does not specify diff2 what version of the EVM. I personally, yeah, I'm not, I don't know, I'm not sure if that makes sense, but if that fits better the kind of the needs of the L2s, then of course we could basically do it that way. Yoav?
I think it's. I mean, the question about Pectra, it seems pretty clear that we should start from Pectra because it will take time to launch for anyway. But the more general question is what happens in future L1 forks. Can we decide that the common core always starts from the current, so it always includes all the current L1 features? So like when we move to Fusaka, it's also assumed that the common core is now based on Fusaka.
I think we're having a few misunderstandings here. Like having something implemented, if the common core is the rollup Geth code base, then that code base does not define the spec for what's being run on the rollups. Like even today, like multiple layer 1 chains can be using the same get versions, and they can have different EIPs activated on each chain, right? Like the fact that you're using the same version of the client, that you're using the same rollup get or whatever, does not mean that you have the same spec of the chain, the same features on the chain. And that's even if, so if you want to agree that all of the rollups will have a set of features activated at some point in time, that's not even a decision to be made on the common core perspective. Like we from the on the code would not have to do anything different to support that. Like that's something that has to be coordinated on the social layer, that the different chains will activate the feature at the same time. But that's not something that you do on the code. You do not
So I
touch.
think
Right.
no,
I think
no,
there's
so it's when I want to make a distinction, to make a distinction, common core and rollup get are two different things. So rollup get is an implementation, but there are also other implementations, other clients like Aragon and Aragon Nevermind and others will also implement it. So the common core is actually the social coordination of what should be turned on by default. And then anyone can decide to turn on other RIPs, whether they are based on a rollup get or on another client. But the agreement on common core is a set of RIPs that everyone implements. So my question was not related to the code, but more on the coordination layer, which ones, whether we always base everything, whether all the rollups agree to always use the latest L1 specs as the basis.
right. Yeah, just to clarify, because I do think that there was some confusion around this. Yeah, so those are basically in different things. You can think of them as like a Venn diagram of expanding scopes, where basically you have the L1 spec at the core. Then you have the L2 common core spec, which is really a list of features that the individual L2s that opt into this would commit to shipping in full and supporting in full. And then you have basically as an even larger set of features would be just like the de facto IPs that are say ideally it would make sense to coordinate across the L2 clients there as well. Basically the list of IPs that are supported by all the L2s that can be enabled in an opt-in basis. So I think today if I'm not mistaken, all clients support. I'm not actually sure if all the clients yet support the R1 curve, but basically once that is the case, that's not yet, of course, part of any common core or something, but it's still basically available by the individual clients. And then the next most kind of shell would be like L2 specific, or like say L2 stack specific features. But basically, yeah, the distinction is important, that like the common core is the actual social coordination decision for people for shared features. And that is only a subset of the features that are available in the code bases of the L2 clients, if that makes sense. Do we have comments on that? Otherwise, I wanted to get back to what Jorf was saying for the forks as well. That maybe first the two raised hands here. How do I pronounce that? Tisahi, or like what?
Tahi.
Tahi. Okay. Go
Yeah.
ahead.
So when you're talking about when exactly Arbitrum will support Pectra, the answer is probably never if you're talking about supporting exactly Pectra, because Arbitrum doesn't support exactly London or anything else, because there are things we change, right? The block number doesn't behave exactly like it is defined in the EVM. We don't accept, you can't post blobs to Arbitrum, and there is a good reason to believe you would never will be. So I think it makes sense to say that yes, Common Core is based on Pectra. It will go forward with when mainnet goes forward. It should absolutely be based on like more or less the current / next hard fork. But keep in mind that being based on Pectra does not mean following everything that's that Pectra says necessarily, because some of it doesn't make sense for rollup, some of it will be different. So if you're really going for a good definition of a common core, you probably need to start with all these places where rollups are already different from mainnet and where they won't stop being different. And that's not a lack of EIPs.
Yeah, that makes sense, Charles.
So +1 to that comment. It's important to find out what are the differences and to write them down and say, here are the differences. I think it makes a lot of sense to say we're aiming to base on the current EVM every time that changes, but you probably need to explicitly look at each change. So every time there's a hard fork, you look at it and say, okay, is there something that this changes in the common core? Is there something that's going into the hard fork that it's not going to go into rollups? But then go in terms of what is a common core, you have a spec of things. It would be stupid to have a spec of things that no one implements, obviously. You can have things that not everybody implements because you can set the versions as a target. And how do you manage fragmentation and difference? It's like there's no magic rule on getting this right. It's a social process of what do we think is enough of this is implemented commonly to be able to say with a straight face, for example, to Eric, saying, here is a common core that if you work with this, you can expect a workable fraction of the market does it now, and more of the market will pick it up. But then it does become important to say, okay, so what are the things where people don't? What are the differences in rollups, and how you manage making that information available, I think is helpful to think about.
Yeah, those are really good nuances. Eric?
Yeah, so continuing from what was just mentioned in the last two comments. So number one, indeed, like right now already, L2s are not exactly implementing the same specs. It's probably makes sense to say that what we care about most on the wallet side is sort of the external layer of it. So the fact that ZK VMs and optimistic, like ZK rollups and optimistic rollups have different implementations entirely internally does not matter to us as long as what they're portraying to the outside world is the same. That might be the way that events are transmitted. That might be like generally different, like the JSON RPC. And I don't have a conclusive list, but basically it's anything that touches the outside world and is not an internal implementation detail. And still, the fact is EVM compatible is not really a defined term. So in some situations, we kind of find ourselves sort of ad hoc defining it. And so when an L2 comes to us, we will ask specific questions. We have like a list of, 20 questions we will ask. And if the answer to some of these questions is no, we might say, well, actually, we don't consider this EVM compatible. Now, maybe we want to get to a place where that soft definition we have becomes a bit of a stronger definitions. And then Common Core does try to be aware of that, like which RIPs are changing those definitions, which RIPs are not changing those definitions. So yeah, anyway, I just wanted to say that like as one statement regarding the last comments. And the second thing I wanted to mention is, or maybe ask, is I think to some extent the first test to Common Core will be what happens after there's an RIP that's being implemented across multiple L2s in a specific way. Then this RIP becomes an EIP, and basically some changes are made or want to be made, right? Suddenly we might end up with an EVM version that is not compatible back to Common Core. Or is that something we have some commitment will not happen? Or if it is something that can happen, what do we do about it, right? That's something that I'm interested in, because otherwise we might end up with like incompatibility between EVMs and the L2s, the mainnet and the L2s, I mean.
Yeah, I mean, this last point, that was also what came up earlier in the call, that I think that's something where we can't really, I think we can't really, it's a little premature to have full answers for this. I think that it's really good to flag that as, hey, going forward, it's actually something where we have to have that conversation with the L1 and figure out basically how this will and end up happening in practice. I think, unfortunately, not unfortunately, but I just think one outcome that is not realistic is a full commitment from the L1 to never deviate from any features, or like if a feature basically is implemented on L1 that already exists in some form in the L2, that it would always use the exact same format for that, because I think the L1 has a very strong feeling of sovereignty that it would not basically want to compromise on there. But of course, anything that doesn't quite amount to that level of commitment, I think there's some reasonable compromises there. I think practically for Common Core, that just means that if the initial version, say the first version, but also like say initial versions, probably will try to just be light on features that could potentially generate conflicts to specifically make sure that any conflicts that might end up happening are kind of small enough in scope to be resolvable. Yeah, then I will say that's actually something that like was not really on my radar, which is I guess it's a bit silly, but like yeah, which is a really good question. It's basically so EVM equivalence is of course not a fully defined term, and so there's a bit of a spectrum. Like just because someone is EVM equivalent, I don't think any EVM equivalent L2 literally has all basically follows the L1 EVM spec identically. It's basically more like this is the starting point, and then we have a diff, and we behave differently, and some features we just do not have enabled and everything. That makes total sense. So then the question is, I think we have two choices here for the Common Core. The Common Core could either basically come with the same level of adherence. So if you say, okay, you're part of the Common Core, you follow the Common Core spec, that means that same thing basically, by and large, you are supporting the features of the Common Core, but occasionally maybe you have a slightly different implementation or slightly different version, or maybe some specific feature of the Common Core is just not enabled on your L2 because it's just architecturally not possible. So that would have been my default kind of starting point, my default position. But of course, an alternative choice we can make would be to say we give stronger guarantees. So like if you are following the Common Core, then even though you might not like have like even though your EVM equivalence might not be like extend to all the features of the base EVM, on the Common Core, we basically say that if someone wants to follow the Common Core, it has to be an exact match. I don't know if people have thoughts there, and like how basically whether we should have the same standard of equivalence between general EVM and the Common Core, or whether it makes sense to have a stricter commitment to the Common Core. Tai?
Yeah, I think what I would like to see, or the best case scenario for me for a Common Core would be something that basically defines all the possible diffs, because I think I know that different RIPs, different rollups have different diffs, and we're not going to now go back and change that. But if we have like a place that collects the possible ways, the different ways in which different rollups differ from the EVM, and actually do create some. So I don't know how possible this is, but I think it should be to create some sort of metrics where different rollups can find themselves, and that could be a great. I think that could be great for consolidation, for actually like, making people aware that, okay, this thing, when you're thinking about this part and you're writing a smart contract or a wallet, then this should be a programmable parameter, because different rollups will behave differently there. And then if you account for that, And if you account for this set of things that could be a diff, then you should be compatible with X dozens of rollups or whatever.
Right. Yeah, I think that's like an interesting that would be a really nice thing to have. I'm not sure if that would specifically be that like a collection of diffs like that would live under the common core or even the roll call kind of process, or if that makes more sense independently. I know that in the ecosystem there are already um, attempts like that. So I know that there's a rollup.codes, which I think does a really good job with basically something that's already kind of similar in a sense. So maybe that could be folded into that. Um, I do think that like once we have a common core version 1, it would make sense to ask a question more narrowly there as well. So like for example, it could make sense to document as part of the common core process um, basically which L2s follow the common core in general, but then also say for each L2 maybe some annotations of like, well, this L2 follows the common core, but with this one kind of difference in this one feature or something. So I think once we get closer, that should be on the list of things to be figured out. Yeah, were there other comments on like say the common core adherence? To what extent that should be similar to the EVM equivalents, or do we want to move to talk about specific candidate features? Okay. Yeah, then let's maybe use the rest of the. I think the call was only scheduled for an hour, right? And so that means we only have 10 minutes left. Clearly, this is something that like will require some time anyway to work towards a common core release. But let's maybe now go through the individual kind of features. I think so far people have been saying that it would probably make sense to be based to have basically the common core start with a base on Pectra. So that would mean that all of the IPs here listed as part of Pectra would basically by default be already part of it. Then maybe no need to discuss those. Right. So I think in terms of other features, it would be interesting to hear specifically like what people think would concretely add value and also be like small enough in scope for them to be kind of interesting in an initial kind of version. I put UF on here, but like I assume this might be a bit large in scope for an initial release. There are other features that are larger, like native account abstraction, that could also potentially be candidates, but also I felt like they were basically too large in scope. Yeah, do people have specific opinions on any of the features listed here, or other potential features that you would want to see as part of an initial set? Harry?
Just kind of related to the previous discussion, I think basically the repricing is going to be interesting, and that I think probably everybody here would agree that repricing would be valuable, but I doubt that everybody here would agree on like what that repricing should be. So like for example, optimistic rollups versus ZK rollups are going to be different here. I'm sure within ZK rollups there's differences. Within chains there's differences. Like figuring out like how to handle that, and like ideally from my point of view, kind of again to the previous conversation a little bit, like more normalizing that there will be differences in pricing seems higher value than like locking everybody into like a single different pricing.
Yeah, that's actually fair. And that was one question I had specifically on pricing. And there's a little bit of that also with the like more standard L2 kind of transaction type, because that also might differ specifically across ZK and optimistic. But I think with pricing, it really is much more clearly the case, because really the optimal pricing differs really a lot from L2 to L2. So there's a good case to be made that this should not be part of the common core set at all. That instead, basically, it's much more something where we should. So there's two parts of it. There's one that just the general expectation, as you were saying, and that's more towards, say, smart contract developers, right? That like they know what to expect in terms terms of how their code behaves on different versions of the EVM. And then there's the actual support. Say, for example, instead of every L2 making individual changes to the gas schedule, it might be nice to have some sort of standard way in which L2 clients now allow for more modularity there. So in that case, that say that there could be some, for example, some version, some IP here that would only define basically more just modularize the gas schedule in some general way that could then be consumed by individual L2s. So that would be an example of this, what Proto was talking about earlier, the kind of these extensibility points. That's something that, yeah, I think could make a lot of sense, but also probably will take some time to get right. So not clear whether that could be a candidate for the first version of Common Core. Right. And if not part of Common Core at all, it could also just be something that we just like use RollCall as a coordination form to both communicate this, like the expectations here to the community and then the developer community in particular, and to say coordinate across the individual L2 clients to support in a standardized way. But yeah, my assumption is that this basically that it really makes sense for the Common Core to focus on features that make sense for all L2s in a very similar way. So for example, the R1 curve is an example of something that I think, for example, I really think the R1 curve would be a really natural fit for first version of Common Core. And they are really it makes sense to have that shared across L2s. Do we have other opinions? I think obviously I mean UF is on here. I would be curious whether people think UF would be feasible. Say if we could get the UF team to basically have a commitment to like a kind of spec freeze so that we make sure that the version that we ship then would also come to mainnet. Of course, that it's a large enough scope that there's always some risk of eventual divergence. So that mainnet maybe makes some last minute changes after all. So that comes with a bit of a risk, I think. Yeah, the R1 curve seems like a very natural fit, and then otherwise the transaction type repricing or any other features, anything that people would want to see. I don't know if you, for example, really think that now is the time for native account abstraction and it should already be part of version 1, then maybe it would be worth just taking the time to make that happen. Nico?
There is another precompile for different cryptographic primitives that is also, I think, quite interesting. It allows different curves. It works with R1, but it also works with ED and Baby Joe and a few other curves. So I think it's an interesting candidate too.
Okay, another candidate that seems worth considering even for the first version is a way to check the layer 1 state from layer 2, whether using a L1 S load or remote static call. This is going to enable so many things that we need, such as trustless bridging or key stores. So I would consider that.
Yeah, that's actually a really good one. I forgot that should have been on this list here. That's a natural candidate. Yeah, is there I'd actually be curious on that one specifically, like an L1 kind of static call or some variant of accessing L1 state. Is that something L2s would be interested in or have opinions on already?
My concern with that stuff is always just what the like performance requirement is. Like standardizing an interface for accessing the L1 block hash like seems like a very clear one. Beyond there, I think it's mostly a question of sort of yeah, node performance requirements. Like, do you require an L1 archive node is always like the big question that comes up on there. And I probably personally, I think like normalizing the requirement that like everybody runs an L2 node has to have an L1 archive node. I wouldn't love, just because archive nodes are a pain. If there are things you can do that like don't have that everybody can agree on, I totally agree. The value is extremely high, since obviously normalizing sort of interop features would be great.
I
Nicola?
think doing just L1 hash is not very useful, especially for optimistic rollups, where you have to actually include the call data of the entire transaction. So having a Merkle proof in each transaction is going to make key stores too expensive to use. But I think we started from this, and actually Ed suggested that it could actually be, you could use it in the fraud proof. You could use the hash as part of the fraud proof, but then actually bring part of the state to layer 2, and not having to include the Merkle proof in each transaction.
Nicola?
Yeah, hi. Actually, this one I already implemented it in the rollup get. So the way it was designed was not to require archive node on the to be implemented. Actually, the idea was that L2s have some notion of the latest L1 block, and that some notion is L2 dependent. I think that Scroll and OP Optimism have this via pre-deployed contract. And if I'm not mistaken, Arbitrum's block number is kind of latest L1 number. Am I correct there? So basically, the way I implemented that feature in rollup get is so that the L2 bringing that code to their own code base can actually choose like inject this notion of L2 notion of the L1 latest block. So basically you can you don't have to rely on that being smart contract or whatever. You just inject it in the function call and everything is kind of modular. So yeah, I think that nice thing is that it doesn't require archive node actually.
Ty?
Yeah, as we're nearing the end of this meeting, and especially given the last comment, I think it makes sense. We were told, let's create consensus among L2 about what needs to be in rollup get and then have it. I think if there exists a good forum to create such a consensus, then I'm not aware of it. And that would be like one thing I would like to see come out of this meeting is anything, I don't know, a Discord channel, whatever makes sense to have a mechanism to make that conversation amongst L2s and rollup get about what should be there and how we get it there and move stuff around.
Right. I mean, I assume there's two variants, right? Like there's it could make sense that like these interactions are on a L2s with each individual L2 client basis. So like the L2s that for today only use get have that channel with rollup get, and then the L2s that use Reth do that with the Reth team and so on, or to have a shared kind of communication channel that has all the L2 clients present. Yeah, I would say the best thing to do here would be to follow up async. And the nice thing is we have the roll call, the next roll call in a week. So the idea would be to make some decisions about next steps and then present those there as well. But yeah, I think of course we have to figure out a way to iterate on this asynchronously as well. Yeah, we're about to have to wrap up. If there are any last comments, Nico, you had your hand up, or?
No, that's it. You explained everything. Just wanted to mention that we have the Telegram group and the Discord channel already. And if you're not there, just feel free to reach out to us, and we will add you there.
Sounds good. But yeah, just to clarify one last time, right? Like though this effort is about like kind of a commitment by L2s that want to participate on to like a specific feature set, and then that would be across implemented and supported by multiple L2 clients. So this is like an effort that is separate from the Rollup Geth project, which in turn is a project that is focused on adding L2 specific functionality on top of the Geth code base specifically. So just to make that clear one more time. Yeah, so then this was a good kickoff call. We ran a little bit out of time towards the end, but yeah, I think it makes sense to just keep iterating towards a first list of features. And then once we have that, I think a lot of these questions around specific decisions, who would actually want to support this? How do we actually support this in particular? Like, should it come with a explicit list of diffs of actual implementations and things like that? I think all of that makes sense to figure out as we get closer to an actual first version. But yeah, thank you everyone for your participation, your feedback, and yeah, let's see most of you or some of you all next week on the normal roll call. Bye.
Thank you.
Thank you. Thank you.
So,
Thank you.
Thank you.
Thanks, everyone.
Yeah, bye.